Alright, so the lesson objective for this video is students will find the volume of prisms and cylinders. So we've been finding area, which is in square units. Whenever we do volume, volume is in cubic units. So for instance, you could have feet cubed or meters cubed, etc. It's in cubic units. Alright, so volume congruence. If two solids are congruent, then they have the same volume. Which makes sense. If they have the same dimensions, they're going to have the same volume. And volume addition is when we're dealing with composite solids. So for composite solids, the volume is the sum of the non-overlapping parts. The volume is the sum of the non-overlapping parts. Okay, so for instance, if I look at this first figure, I can think of it as two boxes side by side. And so I can find the volume of the first one and the volume of the second one. And I know altogether it's just going to be 3 plus 4, or 7 units. Sorry, cubed. I'm using my wrong exponent here. Cubic units. So it would be 7 cubic units. Or for instance, here I've got a cone and a volume. I would just take the volume of the cone plus the volume of the cylinder. And that would give us the total volume. So when we're talking about volume, we're talking about how much space something takes up, or how much it could hold. Like if I were to fill it with water, how much would fit in there. Whereas surface area, we were talking about just the outside of a figure, as if I was wrapping it in wrapping paper. So surface area is like wrapping paper, and volume is like filling up a pitcher of water. How much water would it hold? Okay? Alright, so let's take a look at some specific formulas. If I have a cube, the volume of a cube is just the side cubed. And now you know where that expression comes from. And if I have a rectangular prism, I can just do length times width times the height to get the volume. If I have another type of prism, it's just going to be the area of the base times the height of the prism. So B is the area of the base. H is the height of the prism. So, supposing I wanted to find the area, or the volume rather, of this hexagonal prism, I would have to find the area of the hexagon. So we draw our little triangle here in the middle, which is an equilateral triangle. And when I draw the apothem, it becomes a 30, 60, 90, and so the apothem is 4 root 3. And so the area of the base here would be 6 triangles times 1/2 base times height. And that would come out to 96 root 3. And the height they gave me is 5. Now, you need to be careful with that because it looks like that's part of the base, but you have to realize that the base is this polygon here. And so you have to imagine if you turned the prism up so that it was standing with the hexagon on the bottom, how tall would it stand? It would stand the 5 centimeters. And so the volume is just the area of the base, 96 root 3, times the height of 5. And that comes out to approximately 831.4, and that would be centimeters cubed. All right, so here's another example. We're going to find the volume of this triangular prism. And so again, my base is this triangle here. So the volume is the area of the base times the height of the prism. So the triangle is my base, and the 2 feet is how high it would stand if it was standing on top of that triangle. All right, so for the area of the base, it's going to be 1/2 the base of the triangle times the height of the triangle, which comes out to 1.5. And so the volume is just the area of the base, 1.5, times the height of 2, and so it would be 3 cubic feet. So what you're doing in your mind is you're kind of standing the prism up so that it's standing like this, and the triangle is on the bottom. So don't assume that the bottom of the picture is the base of the prism. The base of the prism is the polygon. That's not a rectangle. Okay? All right, the volume of a cylinder. It's still the area of the base times the height. And since it's a circle, the area of a circle is pi r squared. And then we would do that times the height. So looking at an example, we're going to find the volume of this cylinder. So I have that the radius is 5 and the height is 6. So the volume is just pi times 5 squared times 6. So that is pi times 25 times 6. And that comes out to 150 pi. That would be the exact volume. And if I wanted the approximate volume, we just put that in our calculator, 150 times pi, and we get 471.2 meters cubed. All right, and so we may have a situation where you have to work backwards and find a missing dimension. In this case, we need to find the radius. So we're going to work backwards using the same formula. The volume is pi r squared h. So I know the volume is 1253, and that's going to equal pi times x squared times the height of 10. So we've got 10 pi x squared. So I need to divide both sides by 10 pi. And again, be careful how you put it in your calculator. Put parentheses around it, or make sure you hit the divide twice. All right, so then I get x squared is equal to 39.884. So I take the square root of both sides, and I get that x is 6.32 centimeters. So when you are given the volume and you're missing a dimension, you just work backwards using algebra. All right, Cavalieri's principle. What Cavalieri's principle says is if two solids have the same height, and the same cross-sectional area, then they have the same volume. So it's important that they have the same height and the same cross-sectional area. If that's true, then they have the same volume. So one of the things you have to remember when you're dealing with an oblique cylinder or an oblique prism is that the height is always perpendicular to the base. So we want to know the perpendicular distance. We don't care about the distance along the edge, okay? So that means I can use the same formulas to find the volume of oblique prisms and cylinders. So if we look here, we've got an oblique cylinder, and I have that the radius is 5 and the height is 8. And so I still can use pi r squared h, the volume, pi r squared, that's my area of my base, times the height. So pi times 5 squared times the height of 8, or pi times 25 times 8, which is 200 pi, inches cubed. That would be the exact volume, and if you put that in your calculator, you get 628.3. Again, inches cubed. That would be the approximate volume. Okay, and so we can also have composites. We can have composites where we add, but we also sometimes have composites where we subtract, where part of it is cut out. So in this particular case, what I have is I've got a big box with a little box cut out of it. So the volume is going to be the volume of the big box, or the large box, minus the volume of the small box. And all the sides on that small box are 1 unit. They didn't put it there, but that's also 1 unit, or 1 foot. Okay, so the volume of my large box, when it's a box, we can just do length times height times width. So the large box, I've got 4 times 2 times the height of 5. And my small box, it's just 1 by 1 with a height of 5. So that comes out to 40 minus 5. And so the volume for this solid would be 35 cubic feet. And that concludes this video. Thank you.